During its 50 years of diesel engine production, Caterpillar pioneered many of the design features and manufacturing developments exhibited by today's engine product. Much of Caterpillar's success can be attributed to its ever-expanding capacity to produce quality engines. For example, at the end of 1970, Caterpillar's engine production space totaled 2.5 million square feet. 10 years later, it had more than tripled, totaling nearly 8 million square feet. And by the end of 1985, engine production space totaled about 10.5 million square feet. Paralleling this early expansion was an extensive investment in advanced technology, engine research and design and systems development. This commitment to engine advancement contributed to features such as consistent quality, low fuel consumption, reliable operation, long service life, and service simplicity. During this growth period, several families of Caterpillar engines were totally redesigned and introduced as new generations of popular designs. One such new family was the 3300 series, introduced in the early 1970s for use in industrial, mobile equipment, on-highway truck, marine, and electrical power generation applications. With over 40 years of proven design evolution and application experience, today's 3300 series engines combine simplicity with advanced technology to produce one of the most reliable products in Caterpillar's engine line. The 3300 series is composed of the 3306, an inline 6-cylinder, and the 3304, an inline 4-cylinder, both with a 4.75-inch bore and 6-inch stroke. 3300 engines are available in naturally aspirated, turbocharged, or turbocharged and aftercooled versions, depending on the horsepower required. 3300 series engines are designed to meet user performance and dependability standards in electrical power generation, petroleum, truck, agricultural, material handling, and marine business. Applications include prime and standby power installations, shallow well drill rigs, well workover rigs, line haul trucks, irrigation systems, four-wheel drive ag tractors, air compressors, workboats, and fish boats. This new generation of 3300 series engines offer increased customer value through standard features that provide optimum durability, reliability, performance, fuel efficiency, serviceability, and installation flexibility. Let's briefly look at some of the features that produce these benefits. Engine reliability and durability are determined largely by component quality. 3300 series engine cylinder heads, blocks, and liners are cast in Caterpillar's foundry at Mapleton, Illinois, which devotes 1.67 million square feet of space to engine castings. Precise computerized control is maintained over the chemical composition of each component. The strength of the block lies in its design construction. A ribbed construction plus high tensile strength iron. Blocks are cast from a special alloy iron with a minimal tensile strength of 35,000 psi. The block has a cast-in top deck cooling shelf that maximizes coolant flow to the top of the cylinder liner where combustion heat is the greatest. This aids heat transfer and extends liner service life. 3300 series engines feature a steel spacer plate between the head and block to strengthen the upper structure and eliminate the need for counterbores. Structural strength and rigidity are essential to long engine life. So, casting changes were made to add material to the web area between the cylinders. Other structural improvements resulted to allow for the higher peak cylinder pressure associated with direct injection combustion systems. These engines utilize one camshaft for the timing and operation of the valve mechanism. The camshaft is cast iron and hardened for durability. Another critical engine component is the crankshaft. The 3300 series crankshaft is a boron steel forging, heat-treated for higher strength and outstanding wear resistance. Journals are finished ground and polished to decrease friction and aid bearing service life. Due to the nature of diesel engine operation, the crankshaft is subjected to extreme stresses. Strength and durability are essential. The patented total hardening process provides a continuous deep hardened surface over the entire crankshaft. The crankshaft core is softer yet tough to allow for flexing and to absorb shocks. Total hardening provides excellent wear characteristics, and the 3300 series crankshaft is regrindable. Front and rear crankshaft oil seals are used to minimize oil leakage around the crankshaft. To prevent the seals from wearing a groove and damaging the crankshaft, replaceable steel wear sleeves are installed on each end of the crankshaft. Oil seals press against the wear sleeves rather than the crankshaft. When necessary or required, the oil seals and wear sleeves are replaced at the same time. Thus, downtime and maintenance are minimized. Main and connecting rod bearings are steel-backed aluminum with a lead tin overlay, a combination with outstanding strength and corrosion resistance. The steel backing provides strength and support for the aluminum bearing surface. It also makes other features possible, one being bearing crush. Bearing halves are constructed so the mating faces partially extend above the parting line of the bore. When the cap bolts are tightened, the bearing mating faces push against each other, forcing the bearing tightly into its bore. This is bearing crush. It contributes to better heat dissipation and prevents bearing movement in its bore, one cause of premature bearing wear. Connecting rods are forged boron steel, hardened and shot peened for extra strength. They're designed with a 9-degree taper at the eye end. The TP design, common to 3208 and 3400 series engines, allows more material to be used in the piston crown area for increased strength and durability. The 3300 series engines using the direct injection combustion system employ a piston that is an aluminum alloy casting with a crater in the piston crown. The crater is a Mexican hat design. Valve pockets are machined into the top of the piston to provide clearance with the valves. Pistons are slightly elliptical in shape to provide a more precise fit at operating temperatures. Heat of operation induces expansion to a true cylindrical shape, which allows the rings to hold alignment with cylinder walls for long-lasting power and good oil control. A 3-ring piston design is used to reduce friction, which increases efficiency and deters wear, while retaining excellent oil control. Top and intermediate rings are a keystone design for resistance to sticking and cylinder scuffing under high load. The top ring is barrel-faced, while the intermediate ring is taper-faced. Both rings are supported by a nickel resist band, cast integrally with the piston. The oil control ring is a spring-loaded design. Base metal for all 3 rings is hardened ductile iron. The piston bore is offset 30/1000ths of an inch to the thrust side of the piston to reduce the amount of piston slap, which reduces cylinder liner pitting when the cooling system is properly maintained. The offset piston pin also reduces noise levels. Piston cooling oil spray jets bathe the underside of the piston crown with a continuous stream to aid heat transfer and to lubricate and clean wrist pins. Lubricating the wrist pin in this manner eliminates the need to rifle drill connecting rods, a method commonly used, but one that tends to weaken connecting rod strength. CAT 3300 series cylinder liners are cast iron for extra hardness and durability. The inner diameter is induction hardened over its full length for improved wear resistance. The radius and adjacent areas underneath the flange where it joins the liner body are rolled and burnished for improved fatigue strength. Both techniques aid liner life. The interface is also honed in a cross-hatched pattern for excellent oil control. Full-length liner cooling provides excellent heat dissipation, again aiding liner life. Caterpillar uses O-ring type seals on the cylinder liner to decrease coolant leakage. Because of the rigid engine design, these seals remain seated and provide excellent coolant control. 3300 series engines equipped with direct injection combustion systems use cylinder heads that are of a new design. The head is a one-piece, high-strength gray iron casting. The one-piece construction aids block rigidity, helping to prevent head gasket failures and coolant leaks. Intake manifolds are cast integrally with the head to eliminate gaskets, reduce maintenance, and improve airflow. Intake valves are one-piece temperature-resistant silicon steel. Exhaust valves are a tri-metal construction. Stems are a hardened steel for wear resistance, and heads are a high-strength alloy with stellite facing for resistance to high operating temperatures. Each time the valves are actuated, they are rotated approximately 3 degrees by valve rotators. This results in more uniform wear for better seating and longer life. Exhaust valve seat inserts are a nickel base alloy. Intake valve seat inserts are stainless steel. At overhaul, both are replaceable. 3300 series engines with direct injection fuel systems offer the following benefits. Low jacket water heat rejection for reduced cooling system requirements, approximately 25 to 30% less. Improved combustion efficiency for improved fuel efficiency, approximately 8%. Excellent cold weather starting. All 3300 series diesel engines utilize the proven multiple pump fuel injection design. Combustion systems vary from direct injection to pre-chambered systems. Caterpillar 3306 truck engines for California and 3300 series engines used in underground mining equipment employ the sleeve metering multiple pump pre-combustion chamber fuel system. Such a fuel system is used to meet mandated emission levels and to satisfy requirements for protection. Other 3300 series engine configurations employ a new scroll-type multiple pump direct injection system. This unit has been in development since 1976 and incorporates a new Caterpillar design fuel pump and nozzle, and it is used on many Caterpillar earth-moving equipment. Caterpillar manufactured fuel injection nozzles extend through the cylinder head into the combustion chamber. The nozzles have 9 holes in the tip that change fuel flow to a fine spray that promotes a complete combustion in the cylinder and results in good fuel consumption. The 3300 series is equipped with a hydromechanical governor which controls the amount of fuel needed by the engine to maintain a desired RPM. Flyweights are driven directly by the fuel pump camshaft. A governor servo gives hydraulic assistance to the mechanical governor to move the fuel rack. For generator set applications, this governor responds quickly to load changes and provides 3% speed regulation with paralleling capability. An electric motor attachment is available for remote speed control. For on-highway truck applications, this governor maintains nearly constant speed over rolling terrain and controls fuel injection between low idle and maximum RPM, the total operating range. This means less shifting, resulting in reduced driver fatigue. Woodward PSG governor is available as an attachment on generator set and marine auxiliary configurations. A standard feature is either isochronous or droop operation when paralleled, and it is easily adjusted. Typically, this governor is used in applications requiring either isochronous or variable speed control, such as generator sets operating parallel. Optional on all engine configurations except truck is an electrical shutoff system. It consists of a solid-state overspeed switch, which actuates governor shutoff solenoids. These solenoids can also be actuated by oil and water pressure contactors. The Caterpillar mechanical shutoff is also available on all configurations except truck. This system provides protection from overspeed, high water temperatures, and low oil pressure. An optional manual shutdown lever located adjacent to the governor allows an operator to manually control the engine by moving the fuel control system to the off position. It is not available on the truck configurations. Chrome alloy timing gears are located under the front housing cover. The crankshaft, idler, and camshaft gears have all been widened for higher front PTO application capability. Helical gear design minimizes sound emissions and adds greater gear contact for increased power transmission. All 3306 turbocharged after-cooled configurations, except generator sets, are equipped standard with automatic timing advance, which optimizes fuel injection timing at various engine speeds. Benefits are improved fuel economy, better engine response, and retarded injection timing for easier cold starting. 3306 industrial, marine, generator set, and mobile equipment engines use a 26-quart oil pan. 3306 truck engines are equipped standard with a 22-quart pan. 3304 engines use a 17-quart oil pan. Caterpillar was the first manufacturer to mass-produce engines using turbochargers and aftercoolers. Turbocharging allows more airflow through the engine and more oxygen to put more fuel to work. This enables exhaust temperatures to be lower, which contributes to long valve, piston, and ring life. Also, the turbocharger compensates to maintain combustion air density as altitude increases. Turbocharged 3300 series engines operate at higher altitudes before duration, compared to naturally aspirated engines. The low inertia turbocharger wheel provides fast response to load changes or accelerator demand. Aftercooling lowers temperature of compressed and heated intake air. This increases air density, which improves combustion efficiency. More fuel is able to be injected into each cylinder for higher horsepowers. Cooler intake air temperatures also provide lower exhaust temperatures, which improve exhaust valve life. Truck, mobile equipment, generator set, and industrial configurations come standard with dry turbochargers and exhaust manifolds. Marine propulsion and auxiliary configurations are equipped standard with water-cooled turbochargers and exhaust manifolds, which are optional on generator sets and industrial configurations. The 3300 series engines are designed to accommodate radiator, heat exchanger, or KEEL cooling. A gear-driven water pump circulates coolant through the engine oil cooler and into the block. Coolant then flows around the cylinder liners and up through water directors, into the cylinder head and around the injection system and exhaust chamber areas. When the engine is cold, the thermostat directs coolant back via a bypass tube to the water pump outlet. As the temperature reaches 190 degrees Fahrenheit, the bypass line is shut off and maximum coolant flow to the radiator occurs. The heat exchanger cooling system, standard on 3300 series marine engines, requires a seawater pump to circulate seawater through the heat exchanger tubes. Jacket water is circulated around the tubes by the engine's jacket water pump. Heat is transferred from the jacket water to the seawater. All KEEL-cooled and heat exchanger-cooled engines must include Caterpillar expansion tanks. In addition, KEEL-cooled engines generally require a customer-supplied auxiliary expansion tank. The engine-mounted Caterpillar expansion tanks do more than provide expansion volume for coolant. They also provide a positive pressure on jacket pump inserts to prevent pump cavitation, provide afterboil volume, vent entrained gases from the jacket coolant. 3300 series engines are available with a variety of attachments to provide application flexibility and add increased value for the user. All factory attachments are designed specifically for the 3300 series. The following attachments are available. Single-stage air cleaner for mobile equipment and truck, standard on marine propulsion, auxiliary, generator set, and industrial configurations. Two-stage heavy-duty air cleaners for marine propulsion, auxiliary, industrial, and generator set. Service indicator for generator set, industrial, marine propulsion, and marine auxiliary. Precleaners for use with standard air cleaner for marine auxiliary, industrial, and generator set. Not compatible with two-stage heavy-duty air cleaners. Manual engine-mounted controls for industrial, mobile equipment, and marine propulsion. Standard on generator set and marine auxiliary. Woodward PSG governor for generator set and marine auxiliary. Governor control motor for speed control from remote locations for industrial, mobile equipment, marine auxiliary, and generator set. Torque limiting device for truck engines to limit engine torque when in low gear to prevent driveline damage. Heat exchanger cooling arrangements which contain expansion tank and engine-mounted heat exchanger for industrial and generator set. Package generator sets available with copper-nickel heat exchanger for use in 85 degree Fahrenheit water. Standard on marine propulsion and marine auxiliary models. Radiators, fans, and fan drives. Flexible fittings and 90 degree elbows available for all models. Mufflers available for remote mounting on generator set. Horizontal or vertically mounted mufflers available for industrial, marine propulsion, and marine auxiliary models. Water-cooled manifolds for generator set and industrial, standard on marine propulsion and marine auxiliary models. Water-cooled turbocharger available for generator set models, included with water-cooled manifold attachment. Flexible fuel lines for industrial and mobile equipment, standard equipment on marine propulsion, marine auxiliary, and generator set models. Oil pressure and water temperature gauges for generator set, industrial mobile equipment, marine propulsion, and auxiliary. Tachometer and tachometer drive for generator set, industrial, mobile equipment, marine propulsion, and marine auxiliary. Engine-mounted instrument panels for marine propulsion. Hood and dash-mounted instrument panel for industrial. Pilot house instrument panel for marine propulsion. SR4 generator available in 1500 RPM or 1800 RPM at 50 Hz and 60 Hz respectively for marine auxiliary and generator set engines. Twin-disc MG509 marine transmission available with marine propulsion engines. Available gear ratios include 2:1, 2.95:1, 3.83:1, and 4.5:1. Enclosed clutches, twin-disc rear-mounted for industrial, mobile equipment, and marine auxiliary. Auxiliary drives for industrial, mobile equipment, generator set, marine propulsion, and marine auxiliary. Hydraulic pump drive for industrial, mobile equipment, generator set, marine propulsion, and marine auxiliary. Flywheel stub shaft for industrial and mobile equipment. Front-end stub shaft for industrial, marine propulsion, and generator set. 12 CFM air compressor for industrial, mobile equipment, and generator set. Electric starting motors for all models. Air starting motors, air valves, and air receiver for generator set, industrial, mobile equipment, marine propulsion, and marine auxiliary. And charging alternators for all models. 3300 series engines are designed to minimize maintenance and repair costs. Reduced service points, simplified maintenance procedures, and accessibility for repair are efficiencies designed into these engines. Accessory drives for air compressor, water pump, and optional power steering are all gear drive, which means no belts to slip or break and no bearings to grease. Caterpillar offers the power steering drive gear only, not the pump. The water pump impeller, bearings, and seals can be serviced from the front without disturbing any water lines or other accessories. To reach the pump impeller, only the front pump cover need be removed. All 3300 series engines feature an adjustment-free fuel system. However, there may be times when the fuel system will have to be checked. In such a case, the fuel system can be removed and tested as a complete unit. This results in more accurate troubleshooting, faster service, and less downtime. Should an injection pump require replacement, the plunger and barrel can be removed and replaced without disturbing other pumps in the housing, and there is no need for recalibration. Caterpillar is dedicated to the design and manufacture of the highest quality products. This dedication does not end at the factory. Unsurpassed product support is as important as any feature on a Cat engine. Product support is more than just parts and service. It encompasses a variety of services to help you get full benefit of the performance and efficiency built into every Cat diesel engine. It means reliable dealer service with a range of support services unequaled in the industry. Parts availability. 24 worldwide parts facilities back up over 1,000 dealer servicing locations in over 150 countries. Rebuilt assembly exchange program reduces downtime at overhaul. Factory qualified dealer technicians get Cat engines back into service as soon as possible. Preventive maintenance services like scheduled oil sampling, for example, can forecast service needs and allow major repairs to be scheduled when convenient. Guaranteed parts availability. In most cases, your Cat dealer and truck or ag equipment dealers can deliver the replacement part you need right off the shelf. But if he can't, he'll get the part in 48 hours or less, or it's yours at no cost.